For those of you who might be new to our various webinars or who have not engaged with Agilicus before, my name's John Chiappetta. I do a lot of the customer-facing activities around here. Pretty excited to have everybody today. We do have a very interesting presentation, one that has been top of mind towards the second half of 2022 and has definitely been growing in terms of interest. And this is around security in a manufacturing environment, and then specifically this notion of an air gap and how to achieve it, how to achieve something that is, meets compliance, delivers results, and isn't compromised by various networking decisions later on. And so we're going to dive into that today, and potentially with that, I will kick things off. What I will encourage everybody to do, I'm sure you'll have lots of questions as this conversation unfolds, so use our chat. I believe it's on the left side of your screen. Feel free to pop anything in there. Either somebody from my team throughout the webinar will address those questions directly, but I will also circle back to those at the end to make sure those are addressed. With that, again, welcome, and let's kick things off here. So, to begin, for those who are unfamiliar with Agilicus, I'll do a brief introduction, but won't spend too much time here. Agilicus, we're a cybersecurity company. Our entire goal is to provide simple, secure access to critical systems from any device. So we do this without using a VPN. The mission is keep those critical systems off the public internet, reduce the time, cost, complexity, all that to connect and support and maintain these systems, and of course, micro-segment right down to the device level. That's really the notion of what we try to achieve. From an industry perspective, we span a lot, to be quite honest with you. These are the ones that are definitely most prevalent for us. We do see healthcare pop up quite a bit, as well as a few others, but these are definitely the biggest nails for us, if you will. Today, the one thing that we are going to break down is probably three different sections of the same topic. So to understand this notion of the modern air gap and what it means in a manufacturing environment, we first have to understand what's the challenge and really define what that challenge is we're all facing, and then move on to really understanding the requirements. So here's the challenge, here's the gap, what are the requirements, what do we need to achieve? This is often framed in the typical OT versus IT conversation, but we're going to explore what that means. And then finally, we're going to highlight how many of the industry leaders are moving towards a new framework called Zero Trust, and how that ensures security across all of their industrial sites and their many networks as well. Diving in, let's start with the basics. When we look at this, what are we trying to achieve when we talk about air-gapped environments? I broke it down fairly simply, but one thing that you'll know is that these span many categories, but they all have a common denominator, and that's cybersecurity. So walking through these very quickly with the aspect in the back of our minds, what we're trying to achieve. Really, we want to protect the networks from both bad actors as well as human error, protect systems from disruptions and outages. We want to maintain control and safe operations at all time. We have some ovens, our customers have some ovens that could be turned into an actual bomb if the wrong person gets in there, if the wrong knobs are turned or levers pulled. But also we want to increase operational uptime. So that means productivity, that means revenue stays up, that means efficiency, right? And then ultimately, we want to protect the organization as a whole. We want to protect the corporate brand, the intellectual property that exists within, and then, of course, the physical security of the employees. And so all of these objectives, like I said, span multiple categories, but we're going to look at achieving all of these from a cybersecurity perspective, as well as where they break down today. And then exploring that, the one thing that I did want to highlight today is a report that was actually just released by IBM. So these numbers are directly out of IBM's report. I have a link bottom right, and we're more than happy to share this presentation after the fact. But in their 2022 report on cybersecurity, these numbers and trends, they're not only relevant to the discussion today, but they're also pretty interesting as well. So moving across the top first, we see 21% of all cyber attacks were ransomware in this last year. And then along with those, 41% use various phishing techniques to trick staff into obtaining access. And then 33% were simply vulnerability exploits. So we're all too familiar with that in an OT world. PLCs can be 15, 20 years old, and the last time they had a patch, if ever, was 15, 20 years ago. And so these are really the biggest categories that we saw in this report. But when we look at manufacturing specifically, manufacturing actually ranks number 1 in cyber attacks within this report. And 61% of all OT attacks were within the manufacturing industry, which paints a pretty vivid picture. Now, of those 61% of attacks, 36 of them resulted in ransomware. So we're talking millions of dollars, per instance. And so I think, I'm not sure if the number was over $1 billion in terms of ransomware and payments, but once you factor in the cost of downtime, the cost to stand everything up again, the actual ransom itself, it's incredibly, incredibly costly. But if we focus in on that 61%, I actually want to take one slide to visualize what that actually looks like. And so I added in this one. It's staggering, to be honest with you. So in anything, they say everyone goes for the biggest nail. And I think this diagram specifically shows that right now manufacturing is the biggest nail. There's many reasons for this. It's legacy technology. Operational technology itself is not built with security in mind. There's non-technical staff who need to access systems. In these environments, remote access is a must. Again, going back to that uptime and the critical nature, it's quite important to see how this breaks down and how others are aware of this as well and are targeting based on those facts. So how does this break down? Let's look at this a little bit. Here's the breakdown of type of attacks between 2021 and 2020. So the blue is 2021, the gray is 2020. There's nothing here in terms of great news, but we're going to focus on a few of these. And so I've highlighted a few on this diagram. We've all talked about ransomware. That's been top of mind for the last little while, so I'm not going to point that out on this slide. But the other 4, server access, credential harvesting, misconfiguration, malicious insiders. These are all growing or at least staying consistent year over year. And this is something that we're starting to see. And I don't think it's a coincidence that all 4 of those are directly tied to simple human error. Somebody forgets they're logged into a server. They get an email about the Christmas bonus from the company this year. The CEO is giving away Amazon gift cards. Sounds nice, but could get you into some trouble there, unfortunately. Somebody reuses their credentials across multiple different locations, software packages, and it just so happens that their Twitter login was compromised, and then all of a sudden they use the same Twitter login as they did for a specific environment, and now somebody can gain access to that. Misconfiguration we've all run into. Could be as simple as leaving ports open and forgetting that that's done. And then, of course, disgruntled employees. And the theme of the conversation today and where this is going to go, it's even worse than that, is disgruntled employees that work for your vendors, somebody that you might not be aware of. So the key to addressing all of these, and what we're going to get into a little bit later in this discussion, is really limiting privilege within your environment and then removing human error from the equation. Of course, this is always easier said than done, but I'm hoping today in the discussion that follows is going to prove that this might actually be easier done than said. So flip the tone a little bit here. The last thing that I want to add, keep in mind all these risks are now being multiplied exponentially by the introduction of IoT, various sensors, and connected environments. The vulnerabilities related to IoT and industrial control systems actually increased at a rate faster than vulnerabilities overall. And so these 2 categories are seeing up to 50% year-over-year increases. So it's quite scary in terms of where this is going from a direction and what people on the outside are targeting, because they know it's a vulnerability and they're difficult to address traditionally. So one last thing that I want to highlight before we really dive into a lot of the meat of the presentation today, I want to highlight one final report. This report was actually done by ISA, a group that some on the call might be familiar with. I'm sure most of you have come across ISA in one form or another. But their report was titled Common ICS Cybersecurity Myths. It's no secret that the OT security and the security of your OT network is entirely dependent on the effectiveness both of network design and how you set up your firewall. And the entire goal here is to ensure that unauthorized access doesn't happen. You set up your firewall, your moat around your environment with the entire objective that people on the outside, people who shouldn't have access, they can't get in, right? Firewalls are a very important piece of that puzzle, but firewalls are only as good as the policies and rules. And again, here that leaves room for human error. So the two things in this article that I want to highlight, one being the myth of the air gap, the other being the myth of the unbreachable firewall. Why? Well, what we're going to get into a little bit, but one question I will throw out there right now is, what happens if somebody gets past your firewall? What next? Can they move freely within your environment? Are you aware that they're going into your environment? Think about it in terms of defense in depth. And so we'll address this later on more directly, but first, let's dive into the topic of the day, the air gap. And so with that, we'll first define what an air gap means, so we're all on a level page for the rest of the discussion. And in terms of the discussion today, an air gap is a security measure to ensure that a secure network, your operational technology network, your industrial network, is physically isolated from other networks. This could be your corporate network, for example. Many networks claim to be air gapped, but what we're going to present to you in these next slides is a little scenario. And I'll give you a hint, but this is considered the but scenario. We all run into it. I run into it on many calls. It's my network is air gapped, but, and what comes up with that is how to give your vendors access today. That is the vendor access scenario. We want to think our air gap is, or our network is air gapped, but when we ask this question, the answer is always, it's easy. You just give them a VPN. No problem, right? Well, we're going to explore in the next few slides what the unintentional impact of this is and why all of these organizations keep getting compromised and ultimately hacked, and that's why you see ransomware. And so diving in this, let's look at the typical approach. So I'm sure most on the call are very familiar with this. Often you have your OT networks, they're completely separate from your IT networks, but all of a sudden you need somebody to support your HMI, prevent that line from going down. What do? Well, the answer is pretty easy today. You give them a VPN, right? Dead simple. In this scenario, you have a valid user connecting to your network to help you out, keep that line operational. At this point, you're still thinking your network is air gapped from the corporate network. Everything is great. Now, what about those sensors, though? Look bottom right in this screen, we see there's some sensors on the factory floor. What about those? Well, it turns out they're actually going to a cloud environment, and somebody who's sitting at the headquarters is using that data. They're accessing a dashboard that's created from that data. And so that creates a question mark. Does that go across the air gap? Now, let's refocus a second on the third-party worker. So if we look at them, well, they're actually not in an office at all. They're sitting at home on a device that is unmanaged. You don't manage it. It's from another organization. You have zero control or visibility over what software packages are installed on that device. And then you created a door on the firewall by providing this VPN in the first place, but unintentionally that also lets everything else through, right? If there's something that comes along with them, if somebody can, if that door is available, somebody can reach it. And just because they don't have credentials doesn't mean they can't exploit it for vulnerabilities and get through. Even worse than that, if we go a little bit further, that VPN that you have, it's on-off access. You either have access or you don't have access. What this means is that a user can, good or bad, can get to anything in that network. So, whether that user has access to other things or not, that user and anything that may come along with that user can go laterally within that network and start to access more things. So this is a network that you thought was air gapped, except the logic changes a little bit. So if we think about the logic, the corporate headquarters over the past few years has spent millions of dollars, invested millions of dollars into IT security. They have fantastic solutions in security from an IT perspective. but they said they're going to separate the OT network from the corporate network to increase security even more. We can't have these networks connected. There's too much going on, even though we've invested millions. But now they're actually trusting a third-party vendor on an unmanaged device to connect from home. And when's the last time anybody patched the printer? I certainly have not patched my printer at home, to be honest with you. So there's so much room for error in this scenario, and organizations invest millions of dollars to air gap these environments, bring in private networks, and then all of a sudden that million whatever dollars spent is now compromised because you just gave someone else a VPN connection to it. So we can start to see where this breaks down a little bit, and really the myth of the air gap, this is why it's busted. At least in the traditional sense. So we looked at this model from the traditional air gap and the definition of it. And the bottom line is the traditional air gap, it's simply no longer practical. They don't take into consideration the needs of the equipment that's being serviced. There's something on the factory floor that somebody needs to access in order to keep that running. That access is now done remotely. There's sensors that go to the cloud environment. That now has to be up and connected all the time. So without a doubt, we have to secure the network, absolutely. But people also have valid reasons to connect remotely. Like I said, that PLC needs to be maintained, needs to stay online, or millions in inventory and revenue can be lost. And at the same time, you look at it from a security perspective, well, that third-party vendor could be an organization like Siemens, and they have thousands of remote staff that are technicians that could support at any given time. That blast radius is huge. Are they at home? Are they in the office? How do you protect that? And so, again, not to mention the introduction of real-time monitoring, cloud environments, dashboards that need to be analyzed and watched, sensors everywhere. The concept of the air gap is fantastic, absolutely. But our conversation today is around making these work in a modern world. We now understand where they break down today and why we have to focus on it. But one thing that I did want to highlight before we go any farther is this one quote that I came across, a former director of Homeland Security, and they once stated, "In our experience in conducting hundreds of vulnerability assessments in the private sector, in no case have we ever found the operations network, the SCADA system or energy management system, separate from the enterprise network. On average, we see 11 direct connections between those networks. In some extreme cases, we've identified up to 250 connections." It's a staggering number. It's something that we don't expect because we think of it as completely separate, but we're starting to see all these ties pop up. So in essence, the traditional air gap creates a false sense of security. They have implicit trust baked into them, and it allows certain individuals behind the firewall. Well, if certain individuals can come through, it means if somebody's savvy enough, they can get through as well. And that's how these attackers are getting in and compromising organizations, unfortunately. So for the rest of this webinar, instead of holding on to the belief within this myth particularly, let's reassess and start to understand the requirements for OT security. We'll provide some concrete measures to address these cyber risks, and then ultimately we have to guarantee and ensure that folks can still get their job done, because that's what it's all about. The money still has to flow, the line still has to work, and the business still has to move forward. We can't impede that. So I do want to reiterate this slide that we showed a little earlier. So remember where we started. What do we need to achieve? Protect the networks, limit disruptions, maintain control, increase uptime, and then protect the organization at large. So with that, what are the requirements? So the challenge, this is our typical OT versus IT conversation. I need access. I need to lock everything down. What are the true requirements here? Well, one of them, people need to get their job done. They have legitimate reasons to connect to these systems, and they have to support those remotely. 2, sites are spread out geographically, and they need to be reached remotely at any time. You can't be at every site at once. You need to have that link. And then 3, we're starting to see new requirements come in. Compliance requirements, either internal or external. Cyber insurance, they're saying you must have multi-factor, must have privileged access management. They're starting to say, if you want insurance, you're going to have to play by our rules. And then, of course, there's global standards. So one that's coming up in 2023, IEC is bringing in new vendor access standards that people are going to have to adhere to. So across all this, it's important to, again, limit privilege as well as the chance of human error. We have to look at our network and say, okay, these two variables, how do we limit this as much as possible? People try to trick staff and even contractors all the time. Could be tricking them to install fake software packages, fake patches, fake updates. It could be trying to transfer them files that introduce malware into various networks. You can't rely on the trust that, I trust this individual because they support me, they're a fantastic vendor, they would never cause me harm. That is probably true. However, they are connected to who knows what. They could have a child at home that accidentally browses the wrong website, gets something on their computer, it walks sideways to that vendor's computer, and then it goes into your network, right? So again, this notion of trust, we have to eliminate that. And obviously that's a notion to the zero trust framework that I mentioned before, and then we'll explore in a few slides. But with all of that in mind, let's reset our understanding of what outcomes we're trying to achieve, and let's think about from our IT organization's perspective, from our IT departments within our organization, what are they trying to achieve? What are they? What's the ultimate objective for them? What's the ultimate outcome? What does that look like? And so the ideal outcomes, and ones we certainly help our own customers with, they want to achieve secure access into any network anywhere in the world. Private network, public network, network on a satellite connection, a cellular connection. They want to be able to access it securely and efficiently. They want a high level of security with their mission critical systems air-gapped at all times. They want improved uptime because vendors need the ability to access in a single click, keep that system up. They can't jump through hurdles, wait for permissions, wait for accounts to be set up. They need access when they need access, which improves the overall reliability, right? Because you can monitor this remotely, because you can monitor these systems from anywhere, because vendors can access the instant they need to access them and have no more access aside from the limited privileges that they need to have, it increases the reliability, the uptime, the overall efficiency of these environments. So for the following few slides, I'm going to dive into the Agillicus approach, specifically how we deliver these outcomes for our customers and what that means in our world. This first slide, I mentioned it before at the start, I believe. Agillicus is an all-in-one solution. From a management perspective, the platform itself handles absolutely everything, and it's all to limit human error, right? How do we take all these decisions where you're making ACLs, you're creating accounts, you're forgetting if that vendor still works for you or not? How do you eliminate that? And so from our perspective, the administrator, all they have to worry about is adding a single email address for the individual who they wish to grant access to. So, if Bob from vendor 1 needs access, what's Bob's email? Put them into the system. That's all they have to worry about. The system handles everything else. From a deployment and workflow perspective, let's dive into this diagram a little bit here. So if we start with the right side, this is your secure OT network. What we do, without any new hardware, we create an outbound-only connection to the back end of our cloud. And this is outbound only, so no open ports, nothing like that, and no network config changes. Once that's done, what that means is nothing on that network is on the public internet. Nothing is reachable, scannable, you can't ping it. It fundamentally doesn't exist. If we now look at the left side of this diagram, when a given user needs to access, once they are added to the system, they simply open up a web browser. Once they open up a web browser, they go to a URL, and two questions need to be answered. Who are you? What level of access do you have? Who are you is answered by they log in with their existing email credentials. You have a corporate email address. I have a corporate email address. We leverage that. There's no password share. There's no workflow to reset a password. Somebody forgets one. The second question, what level of access do you have? That's pre-programmed into our system. The user will never see that. the administrator can say, John has view-only access 24/7, but needs to request access when John wants to have higher privileges, let's say. So user opens up a web browser, they enter a URL, they sign in. At that point, we take two outbound only connections, one from the web browser, one from the site, and we splice those together to make it look like that user was directly on that network accessing something without ever having an inbound connection into that network. So a user only accesses the single resource that they need to access without ever being directly connected to that network. And so instead of mapping users to networks with a VPN and creating a doorway, we map users to resources. And that's how we limit privileges. They can't walk to anything else because nothing exists to them. So it's important to point out that on the left side of this diagram that you see, you'll see multiple users there. So these could be users within your organization, could be users external to your organization. We use their existing identities, their existing corporate email address. Why that's important? Well, if we take the OEM example, Siemens has thousands of remote techs that might need to access to support you. What happens if one of them gets fired? Is your login credentials stored on a spreadsheet that everyone might have access to at Siemens? And if somebody on their team goes crazy and steals that information, can they access your system? Are you aware of that? Do you have a way to check it? So with us, if someone gets fired, they're immediately removed from their corporate Active Directory. It's best practices across all organizations. In most cases, it's before they even get fired from the organization, before they're even aware. At that point, they can't answer the first question of, who are you? They can't log in. So right away, the access is cut off and not permitted. So because of this, because we take that identity and attach it to every single access record, you can audit every single action that's done on our platform, or through our platform. Again, the outbound only connection that I mentioned, it means no firewall rule changes. If something does change within that network, it does not cut off your access because we don't rely on that. We rely on a single outbound only connection through port 443. Taking a bit of a closer look here, again, everything is taken care of by the platform. It's important to realize that there's a lot of complex functions happening, but from the administrator's perspective, you just have to worry about an email address. From the user's perspective, you just have to be able to sign into your work email and you can get access to the resources you need access to. Now, really to map a user to the resource, there's a few things that are happening, and this diagram illustrates some of them. So, we federate identity. User at company A, user at company B, user at company C. They all use their own corporate email address, except you can control them as if they're within your own Active Directory without adding them to it. You can revoke their access, grant their access, put them in groups, but you leverage their identity. We can inject things like multi-factor. So you guarantee that third party uses multi-factor when they connect to RDP or VNC into your environment. And then we protect everything throughout this connection method with things like role-based access controls, web application firewalls, and it's all done through a reverse proxy. So there's many things happening within this, but again, the entire point is that to the users on either side, all of this is invisible. So relating this back to the modern air gap discussion and what we talked about earlier, let's apply this to the air gap scenario. So you have two users, very similar to before. You have a vendor that needs to support your HMI. They're sitting at home. You have a senior leader that's sitting at corporate headquarters that wants to view various dashboards that are linked to the OT network. With Agilicus, we map users to resources without using a VPN or connecting them to that network. So what that means, all they have to do, all those two users have to do, is open up a web browser, and it just works. This could be on their computer, on their home network, it could be on a cell phone, they could be at another customer site. The entire point is none of their traffic goes through your network, and that's how we remove the risk. And that's really the benefit of this, is that they can access regardless of where they are, but all the risks we previously spoke about are completely wiped off the table. And ultimately, users can still get their job done. From the user's perspective, as I mentioned, this is dead simple. it's all invisible to them. They pull up their desktop, they open up a URL, and the system they see is as if they're on that network without them actually being on it. So there's no risk of them moving laterally to another environment within that network. There's no risk of them transferring files because this isn't an inbound connection. It's through two outbound only connections. And then ultimately, it just looks like another web page to the user. So they don't have to be technical to understand this. What we dove through today is really our operational technology case study. And so, coming back to what we're trying to achieve and some of the outcomes that we're shooting for, with us, it's a 15-minute implementation. So you can set this up within 15 minutes. And what you do is you protect your vulnerable systems. All of these PLCs and environments, they don't have security patches. They weren't built with cybersecurity in mind. And so this takes them off the internet and it hides them from all the risks that we traditionally spoke about. You avoid insecure remote connection solutions. TeamViewer is a great example. It caught a lot of heat lately, rightfully so, after a few water plants and what have you had some major incidents around shared credentials and stuff like this. So we have a way to provide secure access in lieu of that. You provide remote connectivity to individual systems, not entire networks. So John has access to Robot Arm 1. There's no way I can accidentally connect to Robot Arm 3, swing it around and hurt somebody who's standing nearby. So you lock it down. You can also audit. When did I connect to that? Who connected to it at 3 p.m. yesterday? What change did they make? And this helps you meet compliance requirements. Like I mentioned, deploying multi-factor, adding privileged access management into your portfolio. But ultimately, this is how you air gap OT resources. You keep them separate from your IT. You've already invested millions of dollars in your IT environment, and yet you've separated this off. So this is how you truly keep it separated and you retain that air gap that you invested so heavily in. Because again, outbound only connections, nothing comes inbound into your network. Of course, you avoid compromising those exact investments, right? With a VPN or a jump box or a DMZ, they all allow people behind your firewall when the entire goal is no one should be behind your firewall. That's the point of it, right? And what happens if they do get behind your firewall? What's next? With us, they're never behind it, and they're only accessing one thing, so they can't go laterally, right? You have to have various precautions, and then we have an audit trail. What do they do? Well, we'll tell you what they did, exactly what they did. And then, this is all about deploying reliable access. So I've had a lot of conversations where individuals will say, well, we got access set up to a manufacturing site to support them, but they made some firewall rule changes and our access was cut off, and all of a sudden when we needed to support them, we couldn't do it. With our way of connecting, you can have whatever network changes you want. It's not susceptible to them. So that access is fully intact no matter what network changes happen, as long as there's an internet connection outbound. What does that mean for our customers and our clients and their clients? Well, ultimately, enhanced security. This idea of a zero trust framework. We are a deployable zero trust in a box framework, if you will. You increase your operational efficiency, right? You allow the vendors who need access to access exactly when they need to access it. You can troubleshoot remotely, and you're not compromising anything that you've invested in to date with something like a VPN. And then, of course, it comes down to the end user, and the user experience is seamless. And this is something that I'd be more than happy to demo for you afterwards, but effectively, it's quite literally as simple as opening up a URL, visiting it, and it's as if you're there with all the security risks removed. So with that, I want to make two propositions. Usually we say more than happy to demo, but I also want to make the offer to have my team, specifically my CTO's team, review, if you're interested, if your network is 100% air gap. We can have a bit of a working session. I will make him and his team available. We can sit down and whiteboard this and discuss it out. I know there's a lot of, many of the conversations I had over the last month, they're going into strategy planning for 2023. Unfortunately, we're that close. And they're re-architecting things based on the current frameworks. NIST is recommending zero trust. IEC is looking at how you incorporate secure vendor access and individually authenticated users. There's new concepts coming into play here. So what I wanted to do, because we're heading into the last month of the year, is make my team available. And what I would say is my email address is there. My name is John Chiappetta, john@agilicus.com. Feel free to email me directly, and I'd be more than happy to set that up. Of course, also more than happy to show off the platform if you'd like a demo, either myself or the general email or info@Agilicus account would be able to help you out there.